Hello everyone, this is Harshad Bajpai and today we are going to discuss a case on capital budgeting. It is about an expansion plan. Now what we have to decide is what is a proper tool to be used, and we have to also explain that why we're using the same tool. Now let us first review the facts of the case. Calmex is a company which has identified that there is a niche market and it can sell water tanks. The existing facility cannot manufacture the water tanks, therefore they have to purchase a new machinery. The decision is whether they should expand or not. That decision we have to take, and this is a capital budgeting decision. Now we have two options. Either they can go for small machineries, but the amount there'll be four machines they can buy, or they can buy a big machine. The potential of the market is 1,20,000 sales of unit that they can do. Either they can buy four machinery of 30,000 capacity each, which sums up to 1,20,000, or they can buy a big machine of 1,20,000 capacity. If they buy the smaller machineries, the cost will be 15 million per machine. That's total 16 million cost. But if they buy a big machine, that will be 120 million. But the difference is that the manufacturing cost per tank is 535 for smaller machineries, but it's 400 rupees for bigger machineries. Now let us solve this case. The thing is, the existing facility of Calmex cannot manufacture. They have to purchase a new machinery, and we have to decide here that should they purchase the machine or not. Now let's review the facts. Total amount of sales is 1,20,000 units. The price is 700 rupees per unit. Now discount rate is 12%. Now we have two plans, plan A and plan B, but the question is, will the discount rate remain the same, 12% for both plan A and plan B? The answer is yes, because discount rate depends upon underlying risk as well as on the opportunity cost. Both the underlying risk as well as the cost, the opportunity cost remain the same. Hence, for both these projects, the plans you're going to use 12% as the discount rate. Here I have mentioned discount rates as 12%, and for both the projects that is 12%. Now let us look into plan A. Revenue will be, as we know, revenue will be the unit sold into what is the selling price. That is 84 million. Okay, 84 million, and we know that this will remain the same if plan A or plan B, does not matter. Let me paste the value 84 million. Let me also for plan B also paste the same value, that is 84 million. Now both of the plans differ in cost. Let us review the cost. Cost per tank is 535, but for plan B it's 400. Now what's the total cost? The total cost will be the number of units I'm selling into the cost of manufacturing one unit. It comes out to be 64.2 million. Okay, because the revenue and the cost have been assumed to remain constant, they will remain constant. Now for plan B also, what is the cost? Cost is number of units sold, that is 1,20,000 into the cost per unit, that is 400. That's 48 million. And now as we know that it will also remain constant only. So it is 48 million. Now the cash inflow which will remain with us is the revenue minus the cost. So let's do 84 million minus 64 million, comes out to be 19 or 20 approximately. This also will remain the same because revenues and costs are remaining the same. Now, we'll deal with project B later. Let's look into present value. We will have to calculate the present values because all these cash flows are coming at different years. You'll have to calculate, except for the cash outflow which is happening today. The present value will remain the same. Now let us look into how we're going to calculate the present value. That is the amount divided by 1 plus discounted. Here it is 12% to the power. I will use the number of year, that is 1. So we get is approximately 17.5 million. Okay, we paste it. So we get the present value of all the cash inflows. As you can see, 19 million has been reduced to 10 million. This is the time value of money. Okay. Now, what we have to calculate now is total the present value of the present value of total cash inflows and the present value of total cash outflows. Okay. Now we'll just use the sum given here, and we'll take 1 to 6 years here and it comes out to be 81 million. Okay, let us check, double click it, and it says sum E19 to E24. That's correct. Okay, now what is the present value of cash outflow? That's 60 million. It remains the same. Okay, now what is our net present value? Net present value is the cash inflow minus cash out. The present value of cash inflow minus present value of cash outflow. Therefore, 80,000 plus this one, because it already has a negative sign. Therefore, I will have to use the plus sign. Now the NPV comes out to be 21.4 million. Plan A 21.4 million. Okay. Now let us calculate the NPV for the project B also. Cash inflows. Cash inflow, as we already know, will be the revenue minus the cost. That will be 36 million. Let's copy, paste. It will remain constant. Present value, as we've already done, the amount divided by 1 plus discounting factor, that is 12%, to the power the number of year. Enter. That's 32. Okay, the formula can be used for all, and these are the present values. Now we'll just use the auto sum function. Just we will reduce it to this 1 to 6 here, then enter. Okay, let us check sum. Cell 19 to cell 24. That's correct. Okay, so the total sum is 148 million. Okay, what's the outflow? That is 120 million. Therefore, what will be the NPV? NPV is present value of cash inflow minus, it's already minus, I'll use a plus sign, and 120 million. The NPV comes out to be 28. Okay, let's paste it in the table. Values only. Okay, now which one is greater, plan A or plan B? Plan B is greater, and hence we can give it a green color. So by and large, if we have to choose between these two, we'll choose plan B because NPV is simply greater in plan B. Okay, now let us also look into how to calculate through Excel the NPV value. There is just a difference is we'll have to add the cash inflow, the cash outflow, that is minus 60,000, plus NPV, in bracket. What is the rate which we are using? That is 12%, comma, the values. What are the values on which we are calculating these values? That is D, and from 19 to 24. Okay, parenthesis closed, enter. That is 21. Now we are getting exactly 21,405, 21,405. But this is how Excel can help us do it. We need not calculate. Similar formula. Let's try to use the same formula. Okay, we're getting the same 21,000. This is how Excel will help us calculate the net present value. And also the next thing that we have to calculate is the IRR. Okay, Now let us look into the IRR. The IRR, as you already know, is the rate at which NPV becomes 0. Okay. Now at 12% both are getting positive NPV. Okay. So what we'll do is we'll increase the let us say, let us go for 22%. Okay. Copy and then paste. Control V. Let me do it for both the projects. 22%. Okay. Now project A is having a positive NPV of 2 million, but project B, as you can see here, is having a negative NPV. Therefore what we can say is the IRR of plan B is less than 22 and IRR of plan A is greater than 22. Now to reduce it to 0, we'll have to increase the value. Okay, so let me give it a wild shot and say it is 23.861%. Okay, that's a random guess. It is almost, is it almost 0? But yes, it's very close. It's 411. If you talk about in terms of the 60 million amount, 400 is almost close to 0. So what we can say is our IRR is 24% here. Okay. Now similarly we can do this activity here also. That is 22. Let me reduce it to say 19.55. I don't know. Paste. So IRR is still positive, but it's reduced. Let me use 20%. Okay. When I'm using 20%, it has become negative. So it is between 19 and 20%. It's close to 20%. So let me say that the IRR for plan B is 20%. Now to calculate them exactly, Excel will help us. Just type IRR and then the values. For IRR, we'll also take the negative value and all the positive value, and then comma. You'll have to put in any random number percentage. Let us say 5. Okay, 5%. He'll calculate it. Just once any random number they have to give and enter. So it is telling us about 23.8076, which is an approximately 24%. Okay. Similar formula will apply for this also. The plan B here is equal to IRR. Here is the IRR. All the negative and all the cash flows, comma any random interest rate, enter. It's 19.9, so we can say it's 20%. Okay. Now the payback, discounted payback, you can easily calculate. For plan A it is 4 and for plan B it is 5. Now let us quickly have a review of what all it is here. Now plan A has bigger, plan B has bigger NPV, therefore we'll choose plan B. IRR though is less and discounted payback is also not in favor, but when it comes to the final verdict, we always go with NPV. Hence you're going to choose project B, then project A. And thank you very much for patiently listening for the capital budgeting case study, and I hope that you enjoyed listening to this. And for further queries, if you have, you can write it on my email. Thank you very much. Even if you like the video, like it on YouTube. Thank you.